Hi everyone, welcome back to the course. In the last videos, we have been diving deep into functions, how to define them, how they work with the scope, and how they interact with the closures. Today, we are going to take a step back and look at a bigger picture, functional programming and the pure functions. This is where the JavaScript really starts to shine, and understanding this concept will make you a much better developer. So let's jump right in. Functional programming is a programming paradigm. Basically, it's a way of thinking about and organize your code. This is the meaning of this. What is the functional programming? Okay. In functional programming, we treat function as the main building blocks of our programs. We focus on writing a pure function that don't cause side effect, making a functions reusable and predictable, avoiding changes to data. Instead, we create a new data and passing the functions around like an other value. Okay. Now, JavaScript isn't a pure functional language like the ASCII or the Elm, but it has a strong functional programming features that we can use to write cleaner, more maintainable code. So let's start with the most important concept, and this is the pure function. Now, question is what are pure functions? Second question: a pure function is a function that follows two simple rules. Rule number one: given the same input, it always return the same output. Rule number two: it has no side effects, meaning it doesn't modify anything outside of itself. So let me show you an example of a pure function. Okay, so no matter how many times we call this add with the 5 and 3, we always get 8, and this function doesn't change anything outside of itself. It just return a value, and this is a pure function. Okay, so there is a example of the impure function. Now let's look at a function that are not pure, I mean impure function. The example number one is the modifying the external variables. This is a impure function, actually impure function, because it modify this total variable outside the function. You notice every time we call it with the same input, but we get the different result. First time it give the 5 because the initially total is 0, now 5. Then when I did the same argument, it gives us a 10 and different output from the same input. This is the impure function. Okay, actually where it modifying, actually modify the external variable from here, total equal plus value, and let's modify this value. Okay, another is the function that depend on the external state. So here if you see, discount, price minus discount, and then we are this the price minus discount actually depend on the external variable, right? It's both variable comes from the externally. Price also coming from this function, and discount coming from outside of this function as a variable, right? Even though we are calling this calculate price with the same input, we get the different output because the function depends on the external discount variable, right? That's why when we call this, it give us a 90, then discount is 20, again call, it's give us 80, different output, right? Okay. Now third is function with a side effect. Okay, you see, at first this function num console log this and then return with the num into 2, and this is the side effect logging into console. Okay, this function has a side effect, it's logging to the console, right? Also, while this might seem harmless, it means the function is doing more than just computing a value, which make it impure. Okay, now why are we functions the important? You might be wondering, why should I care about pure functions? So here is the benefit. First is predictable and easy to test. Since pure function always return the same output for the same input, they are incredibly easy to test and debug. Second is no hidden dependency. Actually, you don't need to worry about what's happening elsewhere in your code. The function is self-contained. So that's why there is no hidden dependency. Third is easier to reason. Okay, And when you read pure functions, you know exactly what they do just by looking at their input and output. Fourth is the concurrency and the parallelization. Pure function can be run in parallel without worrying about race condition or shared state. Okay, this all the benefit if we are using this pure function, and that's why it's important. Now converting impure to pure function. So let's take impure function and make it a pure function. First, impure version. Okay, this is the impure version. You see, increment then count. It always increment and then count. But same function, but the pure same function but the pure version. Okay, okay. You see, here is the increment, and we are using here. We just store the count variable. Actually, store a value in the count variable. Then increment is as a increment. I mean count plus plus. I mean increment is count. But here we just create the function that are increase the value count plus 1. I mean returning this count plus 1 in the return statement. Then use the count variable is 0, and then count equal increment count console log, you get 1. When you use this again, then you get 2. And this is the actually the function doesn't modify any external state. It take input and return a new value, and this is a much better. Okay, and next is practical example. So let's look at a real world example with arrays. So first is the impure approach, then secondly the pure approach. Okay, the first version, you notice in this for loop array, this is modify the original array, right? Because we are using this array parameter with the I, right? Then into a 2. Again, then when we are using the function and console log it, we see original array is changed. 2, 4, 6, it's counting. Okay, but if we are using the pure approach, it would be look like this: number, then double array, and array dot map. Actually, it's return the new array map, then num into 2, and you get the double array from here. When you are storing this or assigning this double array in the variable to the variable, then you get this double. Actually, this double actually give you the new array. But if you are inputting this these numbers, you check the original is changed. Originally unchanged, and double actually change the new array, not the original one. Okay. Actually, the pure version create a new array instead of modifying the original one. This is the key principle of functional programming called immutability. Okay. Now, when to use the impure functions? Here is the reality. You can't avoid impure functions completely, and that's okay. Sometimes you need side effect like logging the console, making API call, update the DOM, saving the database. The goal isn't to avoid the impure function entirely. It's to minimize them as much as possible. Isolate them from your pure business logic. Be aware when a function is impure. Okay. So now quickly recap what we learned today. Functional programming is a paradigm that treats function as the main building blocks of code. Pure function always return the same output for the same input and have no side effects. Impure functions modify the external state or depend on the external variable. Pure functions are easier to test, debug, and reason about. We should strive to write pure function when possible, but impure functions are sometimes necessary. So, all right, that's it for this video. Understanding pure functions is a huge step toward writing better JavaScript code. In the next video, we are going to explore the first class and the higher order function, which build directly on what we learned today. These concepts are essential for the mastering the functional programming in JavaScript. If you found this helpful, so don't forget to like and subscribe. Drop a comment below if you have any question about pure function and functional programming. So thanks for watching. I will see you in the next one.